Assalamu alaikum. Good morning, everyone. Thank you for attending this session related to asset management and lean concept. So, first of all, can you introduce yourself?
Yes, sure. My name is Firas Kubail. I'm a planning engineer in the turnaround and major maintenance department.
Thank you, Firas. My name is Mohammed Saeed. I am a turnaround planning engineer in Saudi Arabia and also inspection engineer in SOBC Egypt. We will talk today about asset management and the lean concept. As you know, asset management is a big topic. It cannot be summarized in 4 hours training. But anyhow, we will try to give the important things related to all this subject, and inshallah will be fruitful and mufid. First of all, you know the maintenance. What's the meaning of maintenance? Before maintenance, as you know, in the Stone Age and human area, there are no machines. So maintenance concept was not there. Can you tell me what is the invention time of steam engine?
Not sure, to be honest.
It will be invited in 1712. 1712 was the first invention of a steam engine. From this steam engine will start concept of maintenance. Before there are no maintenance. After steam engine, we'll start of maintenance. And for information, there are 4 generations of maintenance. We will discuss detail in this meeting. Anyhow, maintenance is a big concept. Depend on another factor, not only factors, not only maintenance. We have maintenance for sustain the equipment operating. But equipment who will design, this is another factor called reliability. So if we see now, we will talk today about reliability. Second thing, MTFE, mean time between failure. Third thing, bust up curve. Next, failure rate and pattern. Next, maintainability. Next, availability. And the last one is the session 1, maintenance generation, which we discussed now. Session number 2, we will discuss lean concept. Lean concept, it is American concept. For your information, American is not invite this lean concept. This is taken from Japanese. After the session, I will show you Toyota ways to demonstrate maintenance. So lean concept, it is second generation of Toyota maintenance. I will discuss with you after the session. So we will discuss for this session about workplace 5S methodology, Bosch and versus Bull modes, 7 number ways of lean, which can summarize in T mode, 8 pillars of TPM, total productive maintenance, Kaizen improvement, and TEEP, total effective equipment performance, and the last one, range type and the best practices matrices. So let's go now to first session, understanding of maintenance and reliability. If you see here, maintenance, the objective of maintenance and reliability in an organization to ensure that the assets are available when needed in customer. So here our objective is not only to discuss about sustain or operate maintenance. No, our objective as an inspection or asset or reliability, cost effective. Without cost effective, no need for anything what we do. Cost effective, that's why we come here. We take a salary, we make promotions for cost effective. So it is very important concept in our session. The maintenance best practice, maintenance excellence, world-class maintenance. This is 3 expressions we need to understand. What is maintenance best practice, what is maintenance excellence, and what is world-class maintenance. As you know, in each company, there are concept of maintenance excellence. Some company make this concept as department. Here in SABIC, when I joined here 2017 or 2018, there are department called maintenance excellence, excellence, but nowadays they cancel the department and put under CMT. Anyhow, we will discuss what's the meaning of maintenance excellence, and also best practice and world class. This is concept we'll discuss now. Best practice. Best practice, what I understood from the description, it is the best maintenance attitude and the maintenance doing or maintenance work which gives a company best performance, best availability, best quality, and in the final, high profit and revenue. So, important of this one, increase output of the asset. Same asset, if we do best practice, we will give more output, reduce the need for capital replacement, reduce the maintenance cost per unit, reduce the total cost per unit. So if we follow best practice, we will get 5 things. And the last one, improve performance, cost, and productivity and safety. This is benefits or advantage of best practice. And the next one, increase competitive. Last one, increase market share. For increase market share, do you know what's the meaning of market share? Can you tell us?
What do you mean, like the
In other expression is brand value or copyrights. Here in SABIC, considered as petrochemical company. So they have competitor in another worldwide. SABIC, alhamdulillah, it is second market share worldwide also. So he is first rank, is Germanish company called BASF, BASF. This is company produce more than $7 billion per year. So it is the top rank, and for information, no competitor for this company. It is number one in petrochemical world. Number two, competition between SABIC Saudi Arabia and Dow USA. SABIC, alhamdulillah, last year they make $4 billion output net profit, and Dow USA 3.7. So there are big challenge competition between these two companies. Next company came, it is Mitsubishi Japanese, it is Linde German also, and the last one, Air Liquide, which France company. So market share here, very important in maintenance. So without reliability and maintenance, SABIC will lose the market share. SABIC will lose competitive. SABIC will lose his name. So our maintenance is very important, not only production, not only process, no. Maintenance engineer, maintenance science, maintenance department, very, very important for SABIC. Maintenance excellence. These are very small definitions of maintenance excellence. It will start by maintenance fundamental. You shall know maintenance fundamental. After maintenance fundamental, phase number 2, reliability management. You shall understand what's the meaning of reliability management. Next one, optimizing decision. We shall know, and executive management here, directors, president, we shall take decision optimizing. Optimizing on what? Optimizing on what we can introduce. What is the information you have? So which maintenance excellence help him. Last one, achieving excellence. The stone shows achievement. This is done by achieving excellence. So that's the meaning of maintenance excellence. Asset integrity depends on 3 factors: inherent reliability, operating environment, maintenance plan. So what's the meaning of each one? First one, inherent reliability, mean how it was designed. Now, we have 2 compressors in BB for us. First one in BB3, designed by Sulzer, and second one in BB1, designed by Wison. Sulzer is Switzerland company, and Wison is China company. Check is a different design. Different design give lower performance, lower availability, lower quality. All the time, every 3 months, Wison work, 3 months breakdown. 3 months work, 3 months breakdown. Since we commissioned here 2020, we struggle too much for this compressor because this is concept inherent reliability design of this one. Design of this one is not best design. Next one, operating environment. This is very important issue. You know more than 45 of failures come from operator, come from operational error. So the team was here for Gajadara or for operating our plant. It's very important. These people, it is considered as main person for service value because 45 of failure come from them. If these people have bad attitude, no information, no knowledge, all plant will drop down. Operator must take responsibility. This is very important one. If I am senior manager of operation and I say, Muhammad, Mish'al, Nawaf, Naif, don't have responsibility, my role will take out termination because it will affect my production 100%. Next thing in operator, he can feel if something is wrong, he proper working of the asset. What's the meaning of this point? Now I work with this compressor for 10 years. So I know compressor as I know ferrous. I know compressor as I know my shelter. It's working well today. I take breakfast to go to plant, this compressor will working well. After 1 month I hear there are some different sounds. There are something is not working properly. This is leaking rate increase today. What is happening? I shall have this possibility on form maintenance team directly. Please support. This guy is have illness. This guy have something wrong. Please help him. This is my son. This is my children. So operating shall feel like this related to asset. Next one, operator shows the first defensive watching of abnormal condition. I surprise sometimes, this observation come to our email. Congratulations for Mr. X because he find some abnormality is bland. It's wrong. How this guy come from FMD and ask something wrong? This is observation shall become only from operation because it's the first protection layer for us. Operator can eliminate the reduce the failure. This one, if we apply the first point, this point will become different. Next one, maintenance plan. Mean how it will be maintained. I bring this asset and is working well. How can I maintain it? Say right now, investment $1 billion for new plant. So I am as a maintenance engineer. How can I maintain it? It will be working and waiting is failure. It will be asked some people, please come help me. How can I maintain? I will open the data sheet or open manual of this equipment and be checking. This is okay, but it's not enough. You have responsibility and you have knowledge. You shall know how can maintain this one. So let's start again. What's the meaning of reliability? Reliability, design in or built in, is the result of individual component reliability and how it is configured. What's the meaning of this statement? Now for the column. We have in the column trays, nozzles, bubble cap, demister, and also some inside filter. All this component give us column. So each component of this column have different attribute, have different performance. So if I accumulate all this component in one item, I can know reliability. So this is the result of individual component. The ability of asset to perform its required function. The simplest definition of reliability, if anyone asks for us what is reliability meaning, it is ability of the asset to perform its function. Very easy. Reliability also, it is meaning engineering in most practicable form. I have engineering, I'm studying engineering. What's the meaning of engineering? I study science, numbers, and so on. What is meaning of engineering is reliability. So reliability, I transfer engineering to practical form. I transfer the robots, AI, artificial intelligence, to something can help me, can make me my life easy, can make the production easy, can increase my profits. All this one come under reliability. Next one, it is the probability of the product and the system or service will perform intended function accurately for a specified period of time, with the meaning function of reliability, function of time, and will operate in defined environment without failure. This is RT, have number, and have calculation, and have function. There are mathematical formula to calculate this RT, and we'll discuss now. Last note, in this slide, the objective of maintenance is sustain asset reliability. What's the meaning of sustain? Before 20 years, there are new expression called it sustained development. Its meaning in Arabic التنمية المستدامة. This is new concept to come to all the world. We need sustained development. So meaning of sustain, I keeping the compressor, the column, as the first day he came to our plant. So this meaning of sustain. So now, the objective of maintenance only sustain. Maintenance not increasing the reliability. This point very important. So now if the Wilson compressor, which we discuss now, if I increase maintenance, it will be good? It will be working full year? No, I cannot. Because there are some issue in design and reliability. I cannot increase. So maintenance don't affect on reliability. Reliability is something, maintenance is of other thing. Only common between them, maintenance sustain asset, sustain reliability, keep the asset working in normal conditions. This is meaning of maintenance. Business of reliability, repeat business working every year. Customer specifications, directors and executive management will have it from us. Safety concern, this is reliable assets don't leak hydrocarbons, don't leak oil, don't make fire, so it will save our safety. Reputation, all people say it, no, he has very good assets, it has good reputations. Customer ask for batches, ask for product, ask for body, ask for polymers, for chemicals. Every day I give to him, every batch I give to him. Never ever I say, sorry, my asset have a problem. Next thing, optimization of warranty cost. So warranty cost is massive. And last thing which we discussed before, market share. So now we'll discuss for some mathematical formula. Failure FT is the loss of asset and the ability to perform its required function. So this is failure function of time, loss of ability to perform the function. So we discussed before RT, reliability function of time, FT, failure function of time. So this reliability function of time, machine working, this failure function of time, machine stop. So if we sum two factors, we'll get number one, because this is full day. It's clear for us?
Yes.
Please go to for next reliability block diagram. Now, as we discussed before, I have in the column some component. I have in compressor, journal bearing, thrust bearing, shaft, governor, casing. This is individual component. How can I calculate? As example, no here board. Okay, it is down. Now for the bearing, there are two bearings in the same shaft, or two filters in the same column. This filter, if it is failure, another filter can do his function, can work, can call as redundant for the first one. So in this case, the reliability here can be calculated different than another asset, which if this component stop, all asset will stop. So two expressions will come now. Series and parallel. So two different expressions. Series, if this individual component will affect in all function. Parallel, no, I have another redundant, it can working, but next opportunity I will release. So this one is clear. So now if we check the calculation formula, the reliability of system with multiple components in series calculated by multiplying the individual reliability. What's the meaning of this one? Total R of the system will be R1, reliability of first component, R2, reliability of second component, until Rn will give R total for the system. But for parallel different mathematical formula, it will be R system 1 minus first component, reliability first component, multiplied by 1 times reliability second component, until in Z. So as example, if we have R1 and R2 reliability equal 0.8, so R total 1 minus 0.8, 1.8, so total reliability will be 0.96. This is, if anyone asks us as mentors, what is the reliability of this component, I can give this number after calculation. And from this formula, R total always more than R1 and R2. It is logic as well, must not careful. Now, MTBF, mean time between failure. This expression is very important to calculate the reliability. Now, I have asset. This asset, every 6 months, every 5 months, every 3 months, they have trip for failure, for breakdown, for any reason. So now, after 1 year, my director come to me or come to Firas, please Firas, tell me what is MTBFE for this compressor, for this column. I told them, sorry director, I have some time to calculate it. I go to plant and check whether there are M1 notification, which means breakdown maintenance for this compressor, come in March, one come in July, and it is keeping for 5 days, for 10 days. So it is stop per year for 15 days. So I will divide 2 failure over 15 will give me MTB failure. So let's see here. MTBE or MTBEF stand for mean time between failure and calculated by divide operating time to the total number of failure. As example, it will become in the next slide. If it is working for 5, it is failure as our example 2 times. So I will divide 2 times, multiply by operating time, he working for 350 days. So 2 multiplied by 350 days will give us MTBF. Next one, it is measure how long equipment will work before it's a breakdown. This is meaning of MTBF. Another expression called MTTF, stand for mean time to failure. What's the meaning of this time? This is average time from now until total failure. This one has another calculation. Last one, MTTR. What's the meaning of this one? Mean time to repair. This is very important expression called maintainability. So I have the compressor, the column breakdown. So how many hours required to return to its function? This is called maintainability. Now, as Wilson or Sulzer, he will design the compressor. He shall take care about the maintainability. How can the laborers open the bolt? How can the people change the oil? If it is complex and it's very hard, it will take time, so it will affect in the reputation of the design company. So this is one is very important during design the asset. So we can summarize mean time between failure and the mean time to repair. It is a repairable component. So it's meaning asset breakdown, I will repair. But MTTF, mean time to failure, mean unrepairable component. What's the meaning of this one? As example, in electrical, as you know, electrical field, you have one transistor. This transistor can be repaired? No. So I have mean time to failure. I have 20 months. I can adhere this one until this transistor will be burned. So this is expression mean, this is meaning. It is mean time to failure. It is come for filters, for demisters, for bearing, for transistor, and so on. Will become unrepairable component. Component shall be changed. Alas, no need to keep. Now, example, we have asset. It is working for 2,000 hours, and during the period there are 10 failure. So now I have asset, column, compressor, lamp, anything working for 2,000 hours over 10 failure. So mean time between failure will be calculated as 2,000 hours multiplied by 10 will give 200 hours per failure. So mean time between failure is considered as MTBFE. So if any director asking you what's MTBFE for each component of each asset, it will become like this calculation. And we'll go to another expression called failure rate, lambda. Failure rate of lambda, it is reciprocal of MTBFE. So 1 over MTBFE will give failure rate, 0.0005. Now, what's the meaning from 2 numbers? A larger MTBFE generally indicate more reliable. So if the director or management see high number of MTBFE, he will be happy because the component, alhamdulillah, is more reliable than before. the presence of Firas come here, he make different to our maintenance department. He increase MTB number, MTBFE number. So thank you Firas, thank you maintenance team to make this a change to our SABIC assets. Bathtub curve. This bathtub curve, any mechanical engineer knows this one very well. It is maybe 5 years engineering studies this one. This curve between failure rate and the time. Our asset is started from here, time 0. Come from ABB, come from any company, and started to work. The surprise here, when it start working, after a small period of time, the failure rate start very high. How like this? How failure rate very high? It is new component. This is happening. Why? Because it is called as infant mortality. It is like a baby. When I try to work this one, there are some problem in assembling. There are some problem in formula or homogeneous between the component. So failure rate in the first hour is very high. After 2 hours, after 1 month, after 10,000 kilometers, it will become stable, very low here. So now, this is very called infant mortality. For example, Mercedes company. You know Mercedes company? This company give to you car one time. Manufacturer give to Firas? No. What will do this company? If you go to in Germany and make site visit for this one, they have big track beside company. What is the benefit of this big track? You can suggest?
Yeah, they for testing the cars.
Testing the cars, yeah. So they are working for this car for 10,000 kilometers. Round, 10,000 kilometers. There are one department for this one. After 10,000 kilometers, خلاص, failure rate will go down. For beta will be equal 1. Plus confirming, give the car to the new customer. And for information, the gauge, odometer gauge, start 0 after testing. So it is come as a 0. So the reliability beta will be 1. It will be go the same for 10 years or 20 years, call it constant failure rate, become a boy, become a man. In the end here, you become like old man, and failure rate become increase again because the equipment aging, equipment problem, no proper maintenance, no maintenance team, some company not investment in his people, in his assets, so it will be wear out. Started to failure until reach to last point. This is time to close our asset and close our site. Now let's go to for the next agenda, failure rate and pattern, reliability distribution analysis. As we discussed one more over, there are different components. This component is not easy, as I said, thrust bearing, transistor, filter. It's very complex, too many components inside, too many factors. So I cannot calculate it as serious and parallel. This formula is very simple. So I depend on something called a reliability distribution analysis. It is describes the time to failure as statistical distributions, usually characterized by a specific pattern. So I will enter statistical science to calculate the reliability. Who is the very famous scientist in reliability or statistical? Not reliability, statistical, sorry. This is by Weibull distribution. Called in Arabic منحنى الجرس. You remember him? منحنى الجرس. You take what's the meaning of Asst in high school?
Yes,
This is Weibull or منحنى الجرس. This is very famous scientist for statistical. This guy invite curve for calculating all statistical problems. Weibull distribution is widely used in reliability and live data analysis due to its versatility, diversity, component diversity. Each component has another life, another performance, another attitude, another manufacturer. So this is very useful, this one. Depending on the value of the parameters, the Weibull distribution can be used in modeling a variety of the live behavior. Weibull distribution. Two-factor model distribution can be done by mathematical expressions. It is called probability density function. PDF